the web domain, particularly when people use JavaScript and JSON and Node.js. The most popular option for managing data is MongoDB. So we will see how to interact with MongoDB, how to read and write data to MongoDB. And we will be getting rid of files and using database from now on. And this is the purpose of this session. So I will introduce this and you will apply it in your lab and then apply it to your project. For your project, you need to apply the skills that we learn as we go. So towards the end, you will have everything ready. Okay, so I already presented this diagram before. This is the most common technology stack, how people use together how people use these technologies together to build web applications. On the client side, many people are still using Angular. We will not use Angular. We will use Vue.js. But this stack is called the mean stack. The client side is the only thing different. We will be using Vue.js. On the server side, we have been using Node and Express. The only thing new we will be covering this session is a library called Mongoose, and it helps us to read and write from MongoDB database. On the database side, we will be using MongoDB database, and I will be introducing what this is all about. Okay, so MongoDB is a very popular database, open source database. It is a document-oriented database. So in the past, in the previous courses, maybe in the database course, you mainly studied this type of database is called relational database. This is what you have been studying. So in relational database, the key ideas are, you have tables, and these tables have columns and rows. And you can have multiple of these tables. And these tables will have relationships between them. For example, this is, let's say this is a student table. It has all the details about the student. And this one has the courses table. And one student has one or many courses, and a course can be taken by many students. So you might have a bridge table. Anyway, this is how you have been managing and modeling the data in previously. So relational database is very popular. It's there to stay. But there is alternatives now. Relational database is not the only option. So relational database is not the only option. Another alternative to this type of database is called a document-oriented database. Document-oriented database. So in document-oriented, luckily you are already familiar with this. So basically in a document-oriented, instead of having, let's say, the students and the courses taken by the students in two separate tables, you can put this together in one document. And you can keep this one-to-many, let's say, one-to-many relationships. Let's call this student courses, just to be more precise. So a student has one or many student courses. So you could put them together in one document where you might have, and a document is a JSON document that typically is a JSON document that you are already familiar with. So the JSON format, you already now have a very good understanding of it. It's a very simple data format where you basically open your curly braces and start defining your object in terms of name, colon, value. Name, colon, value. So for example, you might have something like student ID, and the value is 1, 2, 3, and first name, last name, and so on. You might have here date of birth, and so on. Okay, so you define your properties as name, colon, values, and you can see here the value could be a number, an integer. It could be a string. It could be anything you really like. So, for example, let's say, okay. So let's say you have an address. The address. So the address, it's itself an object. So what I can do here, inside I can have a sub-document within the document. So what I'm defining here is a student document. It has all the information about the student, even if one of the properties happen to be a multi-value property. And this is not allowed in relational database. In relational database, each column must have a unique value, one and only one value. You cannot have an object assigned to a column. But this is the major difference. In a document-oriented database, a property could be itself an object. So it could be here, let's say a street. It will be 101 Test Street. It could have city, which is Doha, and it could have a country, which is, let's say, Qatar. Okay, so a property could itself be an object. Now, not only this, it could also have a property as an array of values or an array of objects, such as the courses. So the student has taken or is taking many courses, and you can store these courses themselves in the same document as an array. So you already seen this, something like this, courses. And courses, there are many courses the student is taking. I can open my square bracket and start defining the courses. So each element of the array itself could be an object. So something like this, as a small example. So I have here the code, the course code, which could be something like CMPS 356. The name, the course name, enterprise application development. I could have the, let's say, the grade is B+. What I'm explaining is an example JSON document, and how the JSON document is nothing but set of properties and values, and these values could be really anything. They could be a simple number, a string, an object, or they could be an array of objects. Now, these JSON documents, we have seen how to deal with, how to read and write them and query them when they are stored in a file. So now we will move away from files. We will no longer use files, and we will be moving to managing these documents using MongoDB. Okay, so basically this is, I just would like to remind you here what really a document is. A document, it stores data about certain object, and you, if you wish, you could put all the related data about the object in one entity, in one, what that we call document. You don't need to spread it into multiple entities like we do in a relational database, where we have to store data about same object in different tables, and then we join these tables. We don't need to do this. We can keep the data together under one unit, which is a document. Okay, so far you should be familiar with this. So what is here, what is different here is this MongoDB uses a documents data model. So the unit, the things that we store, retrieve, and get, add, and update in the database are documents. Exactly the same that you have seen previously when dealing with JSON files. Now, these documents are arranged in collections. So a database is made up of one or many collections. Each collection will have a set of documents, And these documents typically will have similar structure or similar schema. So in a MongoDB, so let me just try to picture this for you. So a database is made up of one or many collections, and each collection has, yes, one or many documents. So, for example, you might have in, let's say, something like Banner. Banner as a system, there is a Banner database behind it. So you might have, what type of collections you might have? Let's say student collection. It has all the student documents. You might have rooms collection. It has all the rooms and their details, their capacity, where they are located, and so on. You might have a teacher's document, or let's say instructor's document. You have all the instructors and the documents about instructors. You might have what else? The courses. Although we will see here, I will discuss some more details about this. When you might have courses, they could be either embedded inside the student, or they could be separate and then linked. So I will explain this later on. But basically, you can think of, you can always think of collection in relational database is similar to, is equivalent to table. So because in a relational database, the database is made up of tables. And in the tables, what do we store in tables in a relational database? We store rows. We store rows, yes? Rows of data. And here, in collections, what do we store? Documents. So the equivalent of documents in the relational world is rows. Okay, the equivalent of collection is table, and the equivalent is a document is a row in a table. Okay? So that's basically the idea here. And then what MongoDB allows us to do, it gives us an API to read and write and manage these documents. So this is how the big picture, how it looks like. So here is your application. Okay, it generates queries to read and write to collections, and collections are nothing but JSON documents. And then when you query, you get back a JSON document. That's basically the big picture. The other major advantage of a document-oriented database like MongoDB is you are able to scale the application. What I mean by scaling the application, if you happen to have a large database or a large number of users, you can use multiple servers to host your database. And this is much easier to do than in a relational database, which is much harder to scale. Now, for MongoDB server, you can just go ahead and download it and install it. It's straightforward. It also comes with an IDE called Compass. I will show you how it looks like. You can visually and graphically interact with the database using this IDE. You can also have MongoDB on the cloud. You don't need to install it if you wish, if you don't wish to install it. Like, for example, there is a MongoLab there. It gives you 500 megabytes free. Unfortunately, this is not accessible from QU because the port they are using is blocked in QU, but you can use it from home. And for this course, we will be installing MongoDB. It's easy to install, and we will be using it locally on our own machines. Okay, so this is just to remind you how a relational database model will look like and how it could be translated to a document model. So in here, I have a person that has some details, first name, last name, city, and so on, and they own one or many cars. In a relational database, you must model this as two tables, owner or person and car, and you define a one-to-many relationship between the two tables. In MongoDB, you can just put these two in one document, and you could have the details of the owner, then an array showing each car owned by this particular person. So in here, it's a one-to-many relationship, and all of this information is happily living under one unit, which is the document. Okay, so this is similar. This is what I just explained previously. So basically, what will really change in our application is the repositories. So your repositories so far are using files to read and write. We will change our repositories to use a MongoDB database to query the database and get the JSON. The rest of the applications should have zero change. And this is the power of having a modular, well-designed application. You can change the repository, for example, without impacting the rest of the application. We have a MongoDB database, and now we need to read and write to it using Mongoose. So for the Mongoose is a library. It's an NPM library, very, very popular. You can look. And it allows us to easily interact with MongoDB. And the way we use it, there is a well-defined steps that you need to do for you to make use of this package. So you first do npm install as usual, and then you require it. You acquire this library Mongoose, and then you go through the process that I will explain shortly for you to be able to write to the database and read from it. The first thing you do when you want to use Mongoose to read and write to MongoDB is you need to create a schema. Yes, you basically define in the structure. It's very simple. You already did this when you are defining your relational database. Before you can insert or update or delete or select from tables, what do you need to do first? To create the database schema, to create the actual tables and the structure of each table and the relationships. So this is what is known as the schema. You are describing the structure and the relationship, in this case, the structure of the documents. But let me make it very clear, first of all, here. MongoDB does not require it's a schema. It's a schema-less. The collection, you can just create a collection and start putting documents there. It doesn't care if these documents have the same schema or not the same schema, which is very different than in a relational database. In relational database, you have a table. When you insert in the table, you must respect the schema, and the database will enforce the schema. If you try to insert something that is not aligned with the schema of the table, of course, you will get an error. But in here, in MongoDB, there is no such thing as a schema. But in practice, as programmers, we really need to define the schema of our documents to make life much easier for us. And by the way, they don't need to have exactly the same schema. For example, if you have a student, and that student does not have an address, you don't need to mention the address property. If the student is new, they never took any course, you don't need to mention the course property until they start taking courses. So what I mean by this, although the documents inside the collection are all kind of related to the same entity or the same type of entities, they don't need to have exactly the same schema. Some of the attributes or some of the document properties could be optional. If you don't supply them, no problem. Okay? In relational database, of course, you can also do this, but you will end up with, you say this column accept null. And if the column does not apply to a particular row, what do? You still need to supply it, and you put null inside it. In here, you don't need to mention it at all if it's not applicable or if you don't have information for it. You get the idea. So for us to use Mongoose to interact with the database, the first step is what we need to do. We create the schema of our documents. And based on the schema, we create what is known as a model, which is basically an intermediary. We interact with the model as far as our code is concerned. We will interact with the model. And the model translates our interaction to push our changes or our inserts or our queries to the database. So you can think of it as the model is kind of a bridge that will simplify our lives. We only need to use the model, and the model knows how to translate our interaction with the model to the database. And that's why we call it object document mapper. We deal with objects and this model will be interacting with MongoDB document database. And this model also allows us to, it has a very rich API to read and write, update, delete, and so on. So let me now show you concretely how this looks like. So, yes. Yeah, no problem. Okay, so let me show you, let me first run this small app, and then I'll explain how I made it. So what I have here is a list of books. So I choose this very simple example here. So in this list of books, I have, first of all, I have the book ID. This is auto-generated by MongoDB, and you don't need to supply it. Every document has a unique identifier, and this unique identifier is called _ID, and the value is auto-assigned. Now, a book has an ISBN, which is a unique global identifier that you supply when you create a new book. The name of the book, the title of the book, the category of the book. Is it programming? Is it history? Is it whatever? The pages, how many pages the book has. So these are attributes of the book. Then the book might have one or many reviews. You can add one or many reviews. The book could be in one or many stores. Suppose let's say you are a Jarir bookstore. So you maintain books, and you also maintain which stores this book happens to be at. So you can have the book could be in one or many stores. The book for sure has one or many authors. So the authors, you store it in an array of authors. In this case, I kept it simple. It's just a string. And the book also has a publisher. And here I define the publisher as an object. It has two properties, the name and the country. Okay? So here is a document. Based on this example, for me to use Mongoose to read and write this document to MongoDB, I first need to create what? The schema. So what is the schema? It will define the structure of this document. No, this is an instance. Okay, this is not a schema. This is, so you have here, you have the schema, which is, you can think of it as a class and an object. The class is the schema, and the instance is the object. So the schema is the definition of the structure. While what you see here, this is an instance document that is based on the schema that I will show you shortly. Okay, so let's see how we create a schema in MongoDB. Using Mongoose library. So here it is. Here is the book model. So what I do here, let me show you a couple of things. So for me, before I start using Mongoose to read and write, I must create the schema for my documents. So you remember, database is made up of many collections. For each collection, I have to create a schema for it. What is the structure of the document that will be stored in the collection? So here is an example. So the way I define this schema is very simple. I first go and install Mongoose, and then I require it and assign it to this Mongoose variable. And then what I'm doing here, I'm creating a new schema. And this schema is a review schema. You know how you can go to Amazon, let's say if you buy a book, and you can go ahead and review the book. So in a review, what you typically find, this is what you find. You find the author, you find the rating. The author is a string. So basically here I'm defining the properties and their data type. So the author is a string. The rating is a number. It's 0 to 5. You see here, the minimum is 0 and the max is 5. And then, is it required or optional? It's in this case required. So the schema is defining the properties, the data type of the properties, and some metadata, some further details about each of the properties. In here, the review text, this was an excellent book, or this is a poorly written book. This is the text that you have put. And now created on, when was the review added to our collection? So it is of type date, so the data type is date, and there is a default value. If you don't supply this attribute, or this property, what will be the value? Now, today's date and time. You see here, this is the schema of the review. Are you following? Yes. Is clear? Okay, good, excellent. So now, let's now see the schema of the book itself. So the book, it has an ISBN, which is a string. Of course, I could have done this. It is required if I wish, but I'm just keeping it simple. The title is also a string. Now the authors is, it's an array of strings. Names, comma separated. I can have multiple authors in, I can assign them to the author's property.
An author could have also, let's say, a phone number or something to include with it.
Yes, if I wish to do that, if the author is an object, I can define it like this. Very easy. I can say here, name is a string, phone, for example, or not phone, let's say website. Is a string. Yes, on the fly, I have made the authors as an array of objects instead of an array of strings. And each object is made up of two properties, the name and the website. Okay, but for now, let me just keep it simple. I just wanted to show you various ways you can define the schema. It's very flexible. Now the publisher, there's only one publisher, so it is an object and it has the name and the country. Okay, the category is a string, the pages is a number. Whether we have read this book or not read this book, it's a Boolean. The default is false and it is required. Okay, this is just to show you. You can just keep it simple and just define the data type of the property, or you can specify further details such as the default value and whether it is required or optional. Created on, as I mentioned before, it is date, and by default it will be current date and time. Now, reviews. Have a look at this. Reviews is what? How are we defining the reviews? It's an array of reviews. It's an array of review objects. Now, the review object, the definition of what is a review object, I could have put it in here. I could take this and put it here. That's one way of doing it. I can define the schema of the array elements on the fly in the book schema. Or I can define it outside in a separate schema and then refer to it. So in here I'm saying the reviews is an array of review object defined by the review schema. Yes? So far, what we call this one, for example, here, we call it an embedded object, an embedded document or a sub-document. So we have the book document. Within it, we have sub-documents. So for sub-documents, we have two options. For sub-documents, we have two options. Either we can embed them, or we can link to them or refer to them. Okay? And I will explain later on in terms of design, when do you embed and when do you link? That's another discussion. Okay? That's more a design decision that you make based on some criteria that we will discuss later on. But for now, just keep it in mind. A document can have sub-documents, and this sub-document, they could be either embedded in the main document, or they could be out external, and then we link to them. Similar to foreign key, or similar to, let's say, doing a relationship between tables, as we have seen in the relational database.
In this case,
this is embedded. This is all embedded.
Should we do it as an...
We can discuss. Now, here I'm not demonstrating the best practices. when to use embedding or linking. We will defer that to another session, to later on. For now, what I'm showing you is what a document schema mean, and how do you define it, okay? Now, store, a book could be located in one or many stores. How do I define these stores? It's an array of stores. But this time, I decided not to embed the stores. I decided to refer to them, which means I will have another collection called stores, and I will refer to them. Refer to the stores. Yes, in another collection. In another collection. So the stores will be stored in another collection, and here I am referring to them. So here is how I create a reference to another collection. So here I'm creating a reference to another collection. So all I do, I'll say type. Type is an object ID, and it's referring to which collection? The store collection. This is how I do it. Okay? Yes. Sorry? Okay, so I will explain it. So let's first look at the store. Here is the store. Can you see it? So the store is it's a separate document collection. It's an independent document collection. And each document in the store collection will have how many properties? 2, the name and the city. The name is of type string. Is it optional or is it a must? It is a must, it is a mandatory, it is required. And the city where the store is located is also required, okay? Now, once I create a schema, I can create a model out of the schema. You can think of the model as a collection. So when I say mongoose.model, I'm creating a collection called store, and this collection will have the schema of each document in this collection is the store schema, okay? So this is the store. The store has its own collection, yes? Now, let me just show you maybe this in a more concrete way. So you... Yes. Yes, so I can make use of it anywhere. So the model is basically an object that I can use to read and write to the collection. Okay? So let me show you how this will translate concretely. Let me see if I can find this campus. Yes. So there is this IDE, or integrated development environment, or a visual environment to read and write from MongoDB database. And let me show you how it looks like. So I open it like this. It's a graphical interface. It will ask me which database you want to connect to. I will say I want to connect to database that is currently running on my local machine. It is locally running, and the port in which it is listening, the database, is 27017, okay? And I will say connect. Once it connects, it will show me all the collections. First of all, it will show me all the databases, and within these databases, it will show me all the collections within that database. Okay, so let me show you. One of the databases happens to be called books. And how many collections does it have? 2. So let's go there. Here's the books. I have the stores. Let's start with stores. So the model, I call it store, but when it is actually stored in the database, it is collections, because collection is usually it's stored as a plural, not usually, it is stored as a plural noun, because it has one or many documents. So the store model is mapped to the store's collection. So here is the store's collection, how it looks like. In there so far, how many documents do I have? 2. I have the name, and I have one in Doha and one in Istanbul, and this is the name of the store. Okay?
It's like an object in that case, yeah. Object stores, yeah.
Yes, basically a document. So a document is a serialization in a JSON of an object. So I have an object, I can basically convert it to JSON and then add it to the collection. So a store is a representation of store object. Yes, please.
This is the ID we're going to use this.
Yes.
So we can insert documents through it?
Yes, you can insert here. If you wish, You could insert documents. You can start writing documents here.
So can we also edit other ones?
Of course. Yes.
So basically, we make the schema and make the model, and then we can just.
You can start reading and writing. I will show you shortly. And you can use this IDE to come here and change things. Okay. You can also query here. I can say here where city. You can see here. Give me city. I can query. You can see here the query. You can update, yes. You can do all of this stuff. So this is our store collection, and this is our books collection. Have a look at the books collection. So in here I have the ID, which is auto-generated. I have the publisher, which is an object. Okay, and I have authors, which list of authors in this case, 2 authors. I have the store. Can you see the store? Is it embedded or linked? Linked. So this is a link to the store collection. Yes? Okay. Sorry? Just the ID. Similar to a foreign key. You're familiar with foreign key in a relational database. Let's say you have a student course, and student. So in student course, you put the foreign key, which is student ID, referring to back to the student. When you are referring to a document in another collection, you have to explicitly do it like this. You say store. Store is a property in my book schema, and the store is referring to which collection? The store collection, or the store model in this case, because the store model refers to the store's collection. And basically in here, what I will store in the store property, what I will be putting there, the ID of the store. So now, once you define the schema, all you do is you use the schema to create a model. You can think of it, the model is a representation of a collection in your code. So this model, like let's say the store model, is referring or is kind of a representative of the store's collection. And the book model, here's the book model, is one line of code. Basically, I say here mongos.model book and the book schema. And the book model is representing the books collection on MongoDB side. Now, once I do this, I have now the model. What do I use the model for? To read and write to the MongoDB database. So let me just give you a glimpse of the API, the MongoDB API to read and write. So here is how it looks like. If I have a store, which is a JSON object, if I have a store and I want to create a new store in the stores collection, what do? Store.create, that's it. And I give it the object, it will go and create a new store.
How does it know I'm using the store?
Yeah, because remember, I'm using the store model. The store model represents the store's collection. And the book model represents the books collection. Now I use the model object to add, to query, to update, to remove, and so on. Okay? Now, yes, it will create a new document in the store collection. So the new store could be, for example, Jarir Bookstore, the city is Washington, and it will create it. Okay? Something like that. If I want to get all the stores from the collection, very easy, store.find, and here I don't specify any filters. Remember in the select star with no where clause, you don't have a where statement. You just say select star from students, it will return you all. This is the same. I'll say find, and in I don't pass any filters, so it will give me all. If I don't want to get everything, I just want to know how many stores I have, I call this function count. And I don't give it any filters, it will count. Now, if I want to say, give me the stores in Doha, I can say something like this. City, Doha. It will give me the number of stores in Doha. See, it's very, very powerful. Okay. In here, let's say the books, I'm saying, give me, the books have categories. I'll say, give me distinct categories. No, in here it's a bit different. Don't worry, I will come to this. Let's keep it simple for now. Let's keep it simple. So in here, I want to say, give me a book by ID. You know, everything has an ID. Every document has its own ID. So you can say here, book.find by ID. You give it the ID, you get the book.
That the underscore ID that the Mongo creates?
Yes, yes.
We don't create that.
We don't create it, but you can query using it. You can query the collection using that ID. Yes. No need. So basically, especially in many cases, you don't care about the ID. Let's say, can I think of something? Let's say orders. Customer has one or many orders. I don't need to have my own order ID. If I wish, I could as an extra one. But regardless, whether you have another unique ID or you don't have another unique ID, let's say student, you all have a unique ID, which is student ID. You will have both. You will have the underscore ID auto-created, and if you want to have a custom user meaningful ID, you can also have it. For example, here, ISBN, it's a unique identifier. You can still do find one because you know it's unique. You can see book find one where ISBN is equal to the ISBN parameter that you pass. So this is how you query. So you query using find. You add a new document using create. This is how you create. You can find. This is how you update. Update. You give it the ID and then the new object, the updated object. It will go ahead and update it. This is how you remove. Very super simple. Book.remove. You give it the ID you want to remove, and it will go ahead and remove it. Here I'm returning a promise. This is all done asynchronously. So when I call this from, let's say, from the service, I have to do wait because this is asynchronous. Okay, so I have to return, even if it is just remove or update. I'm not returning the results of the query. I'm returning a promise because remember, this is all asynchronous. Interaction with the database is all asynchronous.